Hola! It's Josie from 7J, and today I have to do a doodlecast on Billy going to space. So here we go, Billy's space trip. Also, I had done this previously, and then realized that the audio got all screwed up. I don't know what happened, but I had already done a lot of really time-consuming drawings, so I just took screenshots of them and edited them into this doodlecast, so please don't pay attention to the time up at the top of the picture, or for some reason a little gray circle appeared in every corner every time I did the drawing. I screenshotted the drawings, so please don't pay attention to that, and let's begin. Okay, so the first scenario is that Billy would go up to space in a rocket ship horizontally, but he wouldn't be fast enough to make a orbit around the Earth, which is a big problem for Billy, because he would, of course, climb and he would go up, and as he was going, he would begin to slow down, and slow, because, my apologies. He would just slow down over time, but never, and then eventually he would stop and plummet down to Earth. Okay, so the first scenario is that Billy launched himself horizontally off the Earth, and he wouldn't go fast enough to make a full orbit around the Earth, which is pretty unfortunate for Billy, sadly. So as you can see, this is a drawing I did, and his ship is launching horizontally off the Earth. So, since he didn't have enough speed to make a full orbit around the Earth, that means that he wouldn't have enough speed to escape the Earth's escape velocity, which is really sad, because he would start off and he'd go fast, and then suddenly he'd begin to slow down, and then he would go to a complete stop, because the escape velocity would just be too much. And then he'd on to Earth, and crash in a fury of fire and sparks and metal flying everywhere, and would probably be killed. Yay. Okay, so the second scenario is that Billy once again launched himself in a rocket ship horizontally off the Earth, but this time he went fast enough so he could make a full orbit around it, which is also pretty bad news for Billy, because as soon as he would launch himself over and make an orbit of the Earth's escape velocity, and because of orbital motion, Billy would be pulled in Sorry, the audio cut off there. So where was I? Okay, so unfortunately for Billy, if he made an orbit around the Earth once, then he would be stuck in this perpetual motion of just going around and around and around and around and around the planet, because once he gets going, because he's constantly falling but continuing to miss, he would never stop. During this time, his speed would probably never change, except for when he is, of course, breaking free of the escape velocity. But once he is in orbit, he will move at a constant speed. Okay, the next scenario is that Billy launched himself upwards, as you can see, but then he was too slow for Earth's actual escape velocity, which for poor Billy means that he would launch himself up and off of the Earth, and then once again would pummel back down to Earth, would slow, and then Earth, and crash. So there's that lovely drawing of Billy crashing, and that's what would happen, sadly. Okay, the next and last scenario, before I explain what orbital motion escape velocity is that Billy launched himself in a rocket ship straight upwards and faster than Earth's escape velocity, which would be good for Billy, because now he's, as you can see, launching upwards, and because he's faster than the escape velocity, he would escape and break free. He would slow down as he went through the escape velocity, and then keep going, and eventually break free of the gravity, of Earth's gravitational pull, and escape velocity, and be able to rocket freely space. And so there we go. There's Billy flying into space. He's obviously very happy. And yeah. So there is a possibility that Billy would end up on Earth doing this, because if he can direct his rocket ship, then he could always steer back. And yeah. Okay, so now I'm going to explain orbital motion and escape velocity. And this time, because I'm just explaining it, sorry, no fancy space scenes or anything. I'm just going to use a really big purple ball. And let's start off with orbital motion. So, orbital motion is difficult to understand, but here's my grasp on it. It means that an object, whatever it is, once it leaves the surface of whatever it's launching from, it will keep falling, but so you'd think that it would go back and hit the purple ball, but instead of doing that, it just always misses because the purple ball is curved, and so the object would just keep going around the purple ball and around and around and around. Yeah. Next up is escape velocity. And basically, around any planet, for now, we're just going to pretend this purple ball will work. Sorry, and here we go. There's this, a gravity field. And escape velocity is the speed that you need to go in order, the least speed amount an object needs to go in order to break free of this field. So say that you needed to be able to go 5 miles per hour to break free of the gravitational field around this purple ball. So if an object was traveling at 4 miles, then it wouldn't be enough. It would keep going until the escape velocity was too much for it, and then it would slow down and pummel back to the purple ball. However, if it was going 5 miles per hour or more than 5 miles per hour, then it would break free of the gravitational field and would float away freely. Yay! So that was my doodlecast on Billy Lovefonda's trip to space and orbital motion and escape velocity. I hope you enjoyed it. The drawings took a really long time. I'm sorry if I don't understand all of it. I hope you enjoyed it. Thanks for watching. Bye!